Good morning, students. Myself, Vijay Shankar from EC Department, Chevrolet Engineering College. Today, we are going to discuss about the remaining properties of Fourier series, the revision class 2. In the yesterday class, the day before yesterday class, we started a revision that is in the second unit, the properties of Fourier series. We already discussed some properties. In the today's class, we continue the remaining properties. Fourth property, scaling property. Till now we discussed about the linearity property, time shift property, and frequency shift property. Now coming to the fourth property, scaling property. Scaling property. Here you have to remember the two words for the scaling. So already we've seen the basic operations on the signals, the time scaling we have. The time is scaling with A. If A is greater than 1, A is less than 1. In the greater than 1, there is a compression is occurs. When A is less than 1, expansion is occurs in the time scale. But in the Fourier series property, the scaling, if x of t, see here, the statement saying that if x of t, the Fourier series x of k, then take the z of t is x of at. What we know this one? We already heard in the basic operation of the signals x of at. Apply the Fourier series for this signal x z of t to get the x of k by using the exponential Fourier series equation only. But have to remember these equations, these statements, not the equations, sorry, these two statements. Since x of t is a periodic, why I am saying is a periodic, the Fourier, remember that the Fourier series is used to analyze the periodic signals only. Once again, I am saying the Fourier series is used to analyze for periodic signals only. See, the x of t is a periodic. If x of t is a periodic, then z of t is equal to x of at is also periodic. Is also periodic, and if t is a period of x of t, see here, it is a very important point. When x of t is a periodic, x of t is periodic. It's a very, very important point, my dear students. If x of t is a periodic, what is a period here? 1 by t, the integral t, we are taking that. T is a period. T, the capital T is a period of x of t. Is a period of x of t signal. Understood, my dear student? Because it is x of t is a period. Now we are taking the x of at. If x of at is also the periodic, is periodic, if x of t is a periodic, is a scaling with a. For x of t, the t is periodic, means for x of at, the t by a. T by a is a period. T by a is the period of x of at. Remember, my dear student, this is a very important. Okay. For x of t is a periodic, means t is the period for x of t. Okay. For x of t is a periodic, means t by a is a period. T by A is a period of x of AT. It's a very important. Z of T will be now then the period of Z of T. Why you are saying the Z of T? Because Z of T is the x of AT only. Z of T is will be the T by A. Okay, in the time it is. Similarly, the second point now you can see, similarly, if frequency of x of t is omega naught, okay, in the terms of frequency, if I am saying the frequency of x of t, the frequency of x of t is omega naught, and the frequency is a frequency. And for the frequency of x of AT, x of AT is A into omega naught. A into omega naught. Now we can modify these two equations in the analysis equation. This is very, very important. When if it is x of t is a periodic, and z of t, x of AT, the period is a t by a. If omega naught is a frequency for the x of t signal, for x of AT will be the A into omega naught. So in the frequency we are multiplying the A, in the time we are dividing with the A. In the frequency we are multiplying with the A, and in the time we are multiplying with the 1 by A, the period. Remember. Then we can see how we can prove that it is a x of k, my dear students. Following the proof. See, I will show that there is a proof here. There is no the proof here. I take the whiteboard and I will explain the proof. The fourth property, time scaling. Time scaling. Time scaling property. What is the statement saying? If x of t, the Fourier series, so listen carefully, my dear students. X of t, the Fourier series, x of k, then you have to prove x of AT by taking of z of t is equal. So z of t is equal to x of AT. Apply the Fourier series. We get x of k only. X of k. What z of s? Z of k. Z of k is equal to x of k. Z of t is equal to when we take the x of AT. Let the proof. So what is the analysis equation saying? X of k is equal to 1 by t integral t x of t e power minus j k omega naught t dt. Okay, my dear students. Now I am replacing the x of t. Means here it is not the x. Little bit confusion will get. I am taking only the z. So z of k is equal to, and it is a z of t. What they are saying, take the z of t is x of AT. Now I am substituting 1 by the t integral t, replacing the z of t as x a of t. Following, my dear students, x a of t e power minus j k omega naught t dt. What we said, when x of t is periodic, t is the period. T is the period. Okay. And if x of at is a periodic, what is the time here? Period. The t by a. T by a is the period. Okay, my dear students. T by a is a period of x of t, and here the period of x of at. So now I am changing this as a t by a here. In the denominator only the t by a. And these limitations is also the t by a one. Okay. Because it is a minus t by a. And what is the frequency? This is the time. The frequency for the x of t, the frequency is omega naught. For x of at, the frequency is a into omega naught. Okay. So when I am replacing this x of at, the frequency changes as a into omega naught. So time period is changes the t by a, and the frequency is increases. So there is a relation is there, my dear students, when the time is decreases. Why I am saying it is a decreases t by a. What is the frequency? Definitely is increases all, because there is an inversely relation between of the time and the frequency. If time is decreases, the frequency is increases. Okay. For this, we are taking the t by a here, means definitely the frequency is increases, because the t and f, or the frequency, is inversely relation between. If this is increases, means this is a decreases. If this is a decreases, means this is a increases. Following my question. So t by a is decreases, means definitely the increases of the frequency. Okay. Now take that. Assume at is equal to m. At is equal to m. What we did in the time shifting property, the replacing of x of t minus t naught as a m. Here also I am taking the same thing. Okay. Then t is equal to, what is the t is equal to m by a. T is equal to m by a. Apply the derivative on both sides. So dt is equal to 1 by a into dm. 1 by a into dm. Don't confuse here. Applying the derivative, we get dt is equal to, because the t is a constant, and the a into dt. And m is also the variable. So dm. So I cross multiply here the a as 1 by a into dm. That is equal to 1 by t by a, means the a will get in the numerator and t will get here. And integral the t by a or whatever it is in the minus infinite to infinite only. So again the value is in the t on the t to t limitations only. X of m, since I assume the at is equal to m, e power minus j k a into omega naught. What is the t here? M by a. T now it is m by a. Omega naught it is m by a. What is the dt? dm. Dt as a dm. Okay, my dear students. Now the a get cancelled here. A get cancelled. and see the 1 by the t integral t x of m e power minus j k omega naught m and the dm. Okay, and this equation actually, this equation is when the a is equal to 1 here, and it is becomes of the same equation. See here, instead of z of t, here is x of m e power minus j k omega naught m and the dm. Simple, it is x of m, not is a small letter, the capital x of k, when this a is 1, a is equal to 1. If suppose it's a a, here it is a 1 only, a is a 1, otherwise it's a 1 by the magnitude of a, you get 1 by the magnitude of a, and a get cancelled there, till finally we have x of k only. The x of t, apply the Fourier x of at, my dear students, x of at for the scaling of time, for the time, applying the Fourier series, you get x of k only, x of k. Understood? Now coming to the another one. So the same thing, x of k is equal to 1 by the integral t x of t e power minus j k omega naught t dt. Substitute the t as a t by a, when you replacing the x of t is x of at, and change this omega frequency also as a into omega naught. Simplify that. Finally, you get the x of k only. Then fifth property here, it is also important, my dear students. Fifth property, time differentiation. Time differentiation. Okay, in this time differentiation, till now up to the 4 properties we are using in the exponential Fourier series. There is a 2 equations we have. One is analysis equation and another one is a synthesis equation. What is the synthesis equation? See here, this is a by the definition of x of t is equal to x of t is equal to sum of k equal to minus infinite to infinite x of k e power j k omega naught t. This is a synthesis equation, my dear students. We already discussed about this. Okay, I will show that also. The previous slides we have, this is C. Here, x of t is equal to, this is a synthesis equation, x of t is equal to sum of k equal to minus infinite to infinite x of k e power, it is a positive exponential, my dear students, e power j k omega naught t as synthesis equation. Analysis equation, mostly we are using for the proofs of Fourier series. The x of k is equal to 1 by t, nothing but is a Fourier series coefficient. X of k is equal to 1 by the integral t e power minus j k omega naught t dt. Omega naught t dt. Understood, my dear students? So now we go today's class. Is the time differentiation. To prove that it is a time differentiation property, we are using the synthesis equation. Synthesis equation, x of t is equal to. Okay. Now that also, if I am taking here in the whiteboard, take the another one. Is the fifth property, time differentiation. Time differentiation. what is a statement saying that if x of t, Fourier series x of k, then to that d by the dt, the derivative of x of t is a Fourier series j k omega naught into x of k, j k omega naught into x of k. Let us see that it is a proof by using the synthesis equation. Okay, what is the synthesis equation saying that x of t is equal to sum of k equal to minus infinite to infinite, minus infinite to infinite. Here, whenever it is output is x of t, the input is x of k, the coefficients. If x of k is the output, x of t is a signal. The positive exponential j k omega naught t. There is no any dt here because it is a summation, not the integral. Okay. Now I am applying the derivative on both sides. Apply derivative on both sides. Apply the derivative on both sides. So d by dt of the d by dt. Now I am applying only for the with respect to the time only. The d by dt is equal to the sum of the k is constant for with respect to the t, and x of k is also the constant, and here the t is there. So d by dt e power not the minus is a j k omega naught t. Following my students. So here only we have the t. Apply the d by dt in the right hand side, in the left hand side the d by dt is equal to the sum of k equal to minus infinite to infinite x of k. What is the derivative of exponential? E power j k omega naught t, and the coefficient of the t. What is the coefficient of t here? J k omega naught. Okay. This is a fact. You see, this is the same equation. Sum of k equal to minus infinite to infinite x of k e power j k omega naught t. Okay, I am rewriting this as the sum of k equal to minus infinite to infinite x of k means j k omega naught x of k, take as a single term multiplied with e power j k omega naught t. What is equal to in the right left hand side the d by dt of x of t. See, what is this equation saying? That x of t is equal to k sum of k equal to minus infinite to infinite x of k e power j k omega naught t means x of t, a relation between Fourier series relation for x of k. Follow my dear students. See, this is the equation saying that if x of t is a Fourier series x of k. Same here, instead of x of t, here the d by dt of x of t, sum of k equal to minus infinite to infinite instead of x of k, that is jk omega naught x of k into e power jk omega naught t1. So there is a relation between the x of t and the x of k is a Fourier series here. Now, in this equation also, what is the relation? The d by dt of x of t is a Fourier series relation. Since here the x of t, I am taking the x of t, the Fourier series relation. Since here the x of k. Instead of x of k, what is the term here? Total term? J k omega naught into x of k. This is a Fourier series relation for derivative factor. The d by dt of x of t, the Fourier series jk omega naught x of k. That only you have to prove. Following, my dear students, x of t, the sum of k equal to minus infinite to infinite. X of k e power jk omega naught t is the equation of analysis when x of t, the Fourier series, is x of k. If same thing here also, if the d by dt of x of t, the Fourier series, is jk omega naught x of k, that satisfies this equation. The d by dt of x of t is equal to sum of k equal to minus infinite to infinite jk omega naught x of k e power jk omega naught t. Understood, my dear students? The time differentiation, the time is differentiated here. T by dt of x of t. If they ask the frequency differentiation, means you can apply the d by dk with respect to the frequency. We are applying the derivative for the frequency. Understood? So linearity property, and the second one is time shift property, third one is frequency shift property, and fourth one is a scaling property. For all these four properties, we prove that the statement given for these four statements, using the analysis equation, we prove the statements. But the time differentiation property is proved by using the synthesis equation. This is a synthesis equation. Okay, remember, to prove the time differentiation property, we use the synthesis equation. The remaining four properties, what we already discussed, we use analysis equation. Following my question. Now coming to the here what they are saying. So the synthesis equation, or the by definition of exponential Fourier series, apply the derivative on both sides, d by dt of x of t, sum of k equal to minus infinite to infinite x of k. After applying the directly here, jk omega naught e power j k omega naught t, rewrite this expression as d by x of t, dx of t by dt is equal to sum of k equal to minus infinite to infinite jk omega naught x of k e power j k omega naught t. We know that x of t is a Fourier series relation of x of k. By using this equation, we can say that d by dt of x of t means for this signal, apply the derivative to get the Fourier series is jk omega naught, the multiplication factor of x of t, jk omega naught x of k, jk omega naught x of k, my dear students. Understood? So that only we already proved here, jk omega naught x of k. Understood?